November 15, 1943. Aberdeen Proving Ground, Maryland. The temperature sits at 34 degrees and continues to fall, the kind of cold that seeps through wool coats and settles into bone. A transport truck rumbles to a halt on the concrete apron, its diesel engine coughing before going silent. Chained to the flatbed is a single captured German Kübelwagen, 1,740 pounds of enemy engineering sitting on American soil. To most of the men gathered around it, this vehicle represents something far larger than steel and rubber. It represents German engineering itself, precision, efficiency, superiority on four wheels. Staff Sergeant Mike Kowalski stands with his collar pulled tight against the wind, 15 years of Detroit assembly line experience etched into his hands. He has spent most of his adult life building American cars, learning their strengths and weaknesses by touch and sound. Today, he is here to see what all the myths are about. The Kübelwagen is lowered carefully from the truck, its olive-drab body emerging from beneath a tarpaulin like a museum piece. Even at rest, it carries an aura of refinement. The body lines are clean, purposeful. Compared to the boxy American Jeeps parked nearby, it almost looks elegant. Intelligence briefings have described it as Volkswagen's military masterpiece, the vehicle that carried Wehrmacht officers across conquered Europe. To the War Department, this isn't just a captured car, it's a symbol. The brass wants a complete technical evaluation, a definitive answer to a question whispered in factories, barracks, and foxholes alike. If German engineering is truly superior, why are American boys dying in European mud? Technical Sergeant James Patterson approaches from the Dynamometer building, clipboard under his arm, breath fogging in the cold air. 5 years at General Motors have taught him discipline, method, and respect for numbers over opinions. He announces the orders plainly. Full technical analysis. Power curves, maintenance requirements, performance limits. Everything goes into Technical Manual TME 9-83. Kowalski nods, already reaching for the hood latch. For him, this is personal. This is Detroit versus Stuttgart, mass production versus precision craftsmanship. The hood pops open with a crisp mechanical click. Kowalski leans in and freezes. The engine staring back at him is nothing like what he expected. Instead of a heavy, cast-iron power plant, he sees a small, air-cooled flat four that looks closer to a lawn-mower engine than a military one. The cylinders are exposed, the layout minimalist, almost delicate. He checks the spec sheet once. Then again. 25 horsepower. That's it. The Willys Jeep across the lot produces 60 horsepower. Even the old Ford model his father drove in the 1920s made more power than this. For a moment, no one speaks. Corporal Tommy Chen steps closer, slide rule already in hand. A Berkeley engineering student before the war, Chen trusts mathematics above all else. He converts the German specifications into familiar units, translating metric into imperial with practiced ease. 985 cubic centimeters. About 60 cubic inches. Peak power at 3,300 RPM. The numbers confirm what Kowalski's instincts already tell him. The power-to-displacement ratio is poor, worse than most civilian vehicles. Patterson writes it all down carefully. This isn't rumor or assumption. This is data. Major Robert Sterling arrives as the inspection continues, his pressed uniform and polished brass marking him as a man shaped by tradition. 20 years of service and a West Point education have taught him to respect European military heritage. He reminds the team of the importance of their work. German engineering has long been considered the finest in the world, he says. Understanding its advantages is critical. Kowalski keeps his thoughts to himself. What they are seeing doesn't match what they were told to expect. As the inspection deepens, a pattern begins to emerge. German engineers made different choices. The air-cooled engine eliminates radiators, coolant, and the risk of freezing, saving weight and simplifying manufacturing. The rear-mounted layout improves traction in snow and mud. But those advantages come with costs. Cooling under sustained load is limited. Maintenance access is poor. Power output is low. This isn't engineering brilliance, it's engineering compromise. The next morning, the dynamometer building hums with energy. Cables snake across the concrete floor, connecting German machinery to American instruments. Kowalski carefully guides the Kübelwagen onto the rollers. The smell of oil and electrical equipment fills the air, reminding him of Detroit proving grounds before the war. Patterson calls out the start of baseline testing. Variables are controlled. Everything is documented. The engine starts easily, it sounds smooth but thin. As load increases, the fan whirs constantly, trying to shed heat. Chen reads off numbers as needles climb. Peak torque at 2400 RPM. Maximum power, 25.3 horsepower. Exactly as advertised. The engine is doing everything it was designed to do. The problem is the design itself. Acceleration tests follow. 0 to 30 miles per hour in 26 seconds. Nearby, an American Jeep does it in 11. Weight comparisons reveal the philosophy behind it all. The Kübelwagen is lighter by nearly 700 pounds. German engineers stripped mass wherever possible. But even with that advantage, the power-to-weight ratio still favors the American vehicle. Sterling watches from above, his confidence beginning to crack. If German vehicles are inferior on paper and in testing, how have their armies moved so effectively across Europe? Transmission tests reveal more surprises. Shifts are smooth, almost luxurious, but the components feel light. Designed for finesse, not abuse. Kowalski imagines 19-year-old soldiers grinding gears under fire. He doubts this transmission would survive long. Cooling tests confirm the worst suspicions. Under sustained load, temperatures climb rapidly. Air cooling simply can't keep up. Patterson notes that the engine cannot maintain military power output without risking damage. Hill climbing tests the following day make the limitations undeniable. The Proving Ground's 12-degree incline defeats the Kübelwagen before it reaches the top. Temperatures spike. Power falls off. At 900 feet, the engine gives up entirely. Moments later, an American Jeep climbs the same hill with power to spare. Chen calculates the numbers. Maximum sustainable grade for the German vehicle, 8 degrees. The Jeep, 27. Traction tests follow. 4 inches of loose sand immobilize the Kübelwagen. Narrow tires and rear weight bias turn minor terrain into a dead stop. The Jeep plows through 18 inches before struggling. Word spreads quickly. Mechanics and officers gather to watch the myth collapse. Maintenance testing delivers the final blow. In an unheated bay, Kowalski begins routine service procedures. An oil change that takes 12 minutes on a Jeep stretches to 45 on the Kübelwagen. Spark plug replacement requires partial disassembly. Air filter service borders on absurd. German engineers protected components beautifully, but buried them. Patterson documents everything. Chen converts minutes into percentages. Maintenance complexity reduces operational availability by nearly 30%. Cold start testing seals the verdict. At 10 degrees Fahrenheit, the Kübelwagen refuses to start. The Jeep fires immediately. Kowalski shakes his head. Game over. By mid-December, the numbers are undeniable. American engineering outperforms German design in power, durability, serviceability, and reliability. Yet the war continues. German units still fight effectively. Late one night, Kowalski, Patterson, and Chen sit surrounded by data, struggling with the contradiction. Finally, the realization hits. They've been measuring machines, but wars are fought by systems. German success isn't built on superior equipment. It's built on doctrine, training, and experience. They extract maximum effectiveness from limited tools. American forces have better machines, but are still learning how to use them together. Major Sterling listens as dawn breaks. The lesson is uncomfortable but clear. Technology alone doesn't win wars. Integration does. Months later, on June 6, 1944, thousands of American jeeps roll onto Normandy's beaches. This time, doctrine matches hardware. Training matches capacity. The lessons learned at Aberdeen have been applied. German efficiency meets American scale and breaks under it. The Kübelwagen still sits in Maryland, a quiet reminder that myths collapse under measurement, and that superiority is never just about what you build, but how you fight with it.